When Ed has finished welding, he must drill holes for the bolts which will further secure the new sheet of metal to the frame of the turbine case. Burning through the holes in the sheet metal is the next step. Inside the turbine case, Ed slides the bolts into the holes he's just burned through. He tightens the bolts outside the casing with a wrench. Then he welds them in. Next, we sand down the red hand. It seems like an endless task. We take turns and bring in some extra help, sanding until we get down to the bare, smooth shaft, where the epoxy is left to fill in the gouges. Later, we're ready to put back the wooden bearing pieces. The bottom bearing, made of the rare hardwood Lignum vitae, is in good shape, and we can still use it. But first we have to pry it apart. Then we can slide the pieces together under the bearing. We assemble the new pieces of the wooden upper bearing and secure the pieces with these 3 metal rods. Then we lift up the whole assembly and turn it over onto the shaft. The wooden thrust bearing is still usable, so we carefully thread it onto the 3 metal rods. The bearing case cover is fitted on next, and Seth tightens the clamps to secure the wooden thrust bearing. While David tightens the bolts on the bearing case. Ed fits the last piece in place in the pressure case wall. It's getting close to the moment when we're ready to let the water through to turn the turbines for the first time. Seth is ready to put the top back on the bearing chamber when the lights go back on, he can bolt it in. The last step before running the wheel is closing the hole in the top of the turbine case. And we've got an audience. The caulking goes on to seal the hole watertight. It's very well documented. We carry the cover over and bolt it on. When the head gates are first lifted and the water flows in from the canal, you can hear it coming a long way off. It takes some time for the pressure case to fill, so we have time to tie up a bottle of whiskey for a little wheel turning ceremony. Ed checks for leaks in the side of the turbine case. Everybody's waiting for the moment. After the first exhilaration at seeing the wheel turn, David focuses his attention on the clunking noise coming from the turbine. The noise turns out to be a loose runner, which we will eventually have to repair. The next set of repairs we're facing involves the pump and hydraulic system for the governor. The oil pump forces oil into and through the governor, but the copper tubing has long since disappeared and we have few clues as to how it once ran. Since this is such old equipment, we've researched old documents to help us figure out how to rebuild it. We start by dismantling the oil pump to clean it and check the parts for wear. The governor must also be taken apart in order to clean it. This new leather belt connects the main shaft of the turbine with the oil pump so that the revolutions of the shaft can power the pump. These broken teeth make this governor gear unusable, but it's an important part of the mechanism. The gear turns the cables connected to the cylinder gates when the governor is engaged. To find a replacement, we turn to one of the other 4 turbine installations on the property. We locate an abandoned governor exactly like the one we're fixing, and scavenge a replacement gear.